another episode of Swaraj Silicon, and this is our episode number 3. And here I have a very special guest, and I'm privileged to host this podcast with Professor Satya, who later turned out to be a startup founder for the ePlane company, which is shaping up the urban air mobility. Welcome, Professor Satya.
Thank you very much.
Can you briefly introduce yourself? Like, what are the other set of ventures, path-breaking ventures that you are involved with other than the ePlane company?
Sure, we'll do that. Yes. I think the broad introduction is that I'm a professor of aerospace engineering at IIT Madras. And besides running ePlane, as I have founded it myself, I'm also a co-founding advisor at Agnikul Cosmos, so 3D printed rocket company, Galaxy Space, which is into Earth observation satellites, and Twitter Hyperloop. As the name suggests, it's into Hyperloop. I'm a faculty advisor to the Avishkar Hyperloop student team. And I'm also a co-founder advisor at Extra Fuels that converts waste into crude oil.
Okay, that's very interesting. And what was the turning point? Like how a researcher and a mentor turn to be, I would be fascinated, and I'm sure my listeners would also be fascinated to know that how a person who is mentoring and especially interested in research turned out to be a founder, especially in building the aircraft space.
Yeah, maybe I was into too much research. Right. So that is to say, I was busy setting up the National Center for Combustion R&D at IIT Madras 10 years ago. And there we were actually doing a lot of deep research on combustion-related topics for jet engines, rockets, coal combustion, coal to biomass, those kinds of things, automotive combustion, lots of such things. Even fire research, fire suppression, spray diagnostics, lots of such things. So we are like a huge operation there with about literally hundreds of PhD students working on these different topics, very closely with industry and so on. The scale of operations was so high, so large that it was almost like industry itself. And we had industry scale setups which were at high pressure, high temperature, and high enthalpies or high energy levels and all that stuff. So having set up all of those and operating them and getting deep research done at industry scale and industry relevance, we also had the opportunity to then use those facilities for diverting some amount of research effort to, let's say, making sprays for the rocket company or for micro gas turbines with low NOx emissions and all that stuff. So those things actually were like the building blocks for these startups in the first place. So if we can develop these engineering setups and operate them at scale, it also then meant that we could also make products of engineering importance and advancement and put them out into the market. So that's how the lab to market story started. And then one thing leads to the other, and we always say that why not this and why not that and so on. So the idea spread that we could actually do a lot more than of the lab to market than just the lab research alone. Yeah.
So, but then what is a USP of ePlane? Like there are a lot of eVTOL companies. What is the USP? I mean, how it stands out globally?
Yeah. So, I mean, to be very honest with you, it's yet to stand out globally because we have to get the product out into the market, and only then the market hypothesis that we have had will definitely stand out. But we do have a market hypothesis like none other. We do think that there is a globally competitive market hypothesis that we're working with, which is to develop the most compact eVTOL in the world in terms of its footprint. And we also try to do this with a fairly slow flying aircraft. And this combination of having a very short wing and flying slowly is an aerospace challenge. Normally, You have slow-flying aircraft like the gliders, which are with very broad wings, and fast-flying aircraft like the fighter jets, which have short wings.
Mhm.
So here we are trying to do the opposite combination. And the reason how we are able to pull that off is to factor in that it's actually an eVTOL. That means it has vertical motors that are going to be around with it, with the aircraft during forward flight as well as takeoff and landing. So we are utilizing the power of these vertical rotors positioned at right places around the wings to enable the wings to operate with a short wingspan as well as with slow flights. Altogether, this means that we can fly multiple short distances in a single charge of the battery, like a typical taxi. So, to summarize, we probably can pride ourselves as the only company that has developed an aircraft particularly for the purpose of a taxi rather than just any other plane. Whereas a lot of other companies make a plane and then try to figure out how to fit it into that use case. Yeah.
Hmm. But is it a safe thing? Like people will be wanting to fly? Will
Yes.
it look safe?
Yes. So that's exactly what all the hard work is about. It's not just about building the plane and flying it, but it's also about how to make it safer.
Mhm.
And the regulations around it on getting the aircraft certified for this purpose are extremely stiff and difficult to fathom. And we are basically up for it. We have to target something like about a 1 in a billion chances of failure.
Okay.
And so that's so a 1 in a billion chances of what they call as catastrophic failure,
Mhm.
and which actually means that whatever failure that happens on board for any component should not be known to the passenger at all. And the practically speaking, and the passenger should just think that the aircraft is still flying normally,
Mhm.
where we have sufficient redundancies in the aircraft that will make sure that it will continue to fly without even a flutter.
Okay. Okay.
Right?
Okay.
So there
Sure.
is about 7 to 8 levels of safety that we have packed into the entire aircraft architecture.
Sure. So, just curious to know, I mean, does it always require a pilot, or is it going to be without a pilot as well, so that you can utilize the third seat as well?
Yeah, that's a good question. We believe that, so we are actually lining everything for the purpose of making it fully autonomous.
Mhm.
I want to distinguish between what's an autopilot and an autonomous
Mhm.
aircraft. So we normally hear about autopilot aircraft, where given the origin destination pair in terms of, let's say, GPS coordinates,
Mhm.
the aircraft can by itself figure out what is the path it needs to take. And it can also factor in waypoints that are given by the air traffic controller,
Mhm.
and can follow those waypoints to make its own path planning
Mhm.
and follow that path it has planned, that has optimized the trajectory for the least time or least fuel consumption or whatever it is,
Mhm.
and follow that path and then take off, fly, land, all of it by itself. That's what's called as autopilot. And that exists today, and it's been utilized very well in the last 20, 30 years, 20 years, more than 30 years, and so on. So to the extent that I think pilots in conventional aviation that we know today are forced to abandon autopilot for at least takeoff and landing, so that they don't lose their practice in flying the aircraft manually. Right? So it's become so commonplace. But autonomous is actually one step more, where it also actually detects um, obstacles and navigates around those obstacles. And these obstacles could actually show up dynamically in front of the aircraft or around the aircraft. Could be like a flock of birds or other flying objects, and so on. And so we need to have a significant amount of sensor suite
Mhm.
that is combined together in a sensor fusion set of algorithms. It could be computer vision algorithms, it could be artificial intelligence, deep learning algorithms that can fuse these sensor inputs together to make sense of what's called as a situational awareness, and inform the flight controller to navigate around these obstacles and still continue to stick as closely as possible to the original trajectory that was optimally planned. for reaching the final destination. So that is what is called as an autonomous aircraft that can effectively remove the pilot from the seat. And we have all of that stack developed with us, and we will be positioning them as pilot assist features in the near term. But to the point that the pilot will not have to operate the craft, but just be there to take control in case it's required. And this is primarily from a regulatory point of view as well as from the public acceptance point of view. So we believe that in about a 10-year time frame from now to 2035 or 2032 to 35, I don't know how soon we can actually get to see this, but my intent is that the passengers who are actually watching the pilot not do anything should start questioning themselves, why am I paying this guy for not doing anything? Right now, the pilot is actually ensconced in a cockpit in a large aircraft, and you don't get to see the pilot not doing anything, right?
Sure.
Whereas here, in this case, we should actually get the passengers to look over the shoulder of the pilot and see that he or she is not doing anything and ask the question, why should we pay for them? And then that's when the public acceptance comes up and then says, okay, fine, we can actually fly the aircraft without a pilot.
So what will be the cost difference, like as against autonomous and driven by the pilot? What would be
That would
the
be
cost
huge.
difference?
That would be huge. So just to give you a sense, to compare the existing aircraft, let us say, right? So for example, if you want to go from Mumbai to Delhi in a plane today, and if I were to make it electric instead of the fuel-based thing, right? And that too, developing an aircraft and manufacturing it in India, the cost of the aircraft itself, the capex, and the maintenance cost because you don't have engines anymore, particularly, and the operating cost with electricity, all of that stuff put together will be 50% of your existing cost, right? So you'll actually completely disrupt aviation as we know it if we just switch to electric, except that today's batteries will not take you that far between Mumbai to Delhi. That's a problem. But you could do Mumbai, Pune, Mumbai, Ahmedabad, those kinds of distances at costs that are about 50% of what it is today. But if you were to remove the pilot out of the equation, the cost will actually drop down to 90% of what it is today. So that's the kind of delta that we're talking about. Yeah.
Then they will certainly question. Okay, and then what is the most challenging thing? Like building an aircraft startup is not an easy thing. So is it a maze of supply chains, or is it the huge set of certifications, or the capital intensive market? Like what has been the most challenging thing?
Well, you listed all of them anyway.
Oh,
Right.
really? No, there must be some hidden thing.
Right, right. No. I think there are people who actually question even more. Like they basically say, do you get the talent required for developing the craft and all those things? Many of these things are not as challenging as some things. I think the topmost thing anywhere in the world globally is the certification part, right? Because we are talking about an aircraft that has to carry passengers over crowded cities. I mean, the damage with an aircraft that could potentially crash, God forbid, is not just about the passengers on board, but also on the place where it crashes. There could be collateral damage of people down below on the ground. So the odds of failure that we have to actually meet is extremely staggering. And therefore, the quality of what we have to do by design, not even by the engineering and by manufacturing, but by design itself, we need to be able to assure a reliability level that's actually so huge. And then we have to prove that with tests and certification. So that's actually horrendous anywhere in the world. That is number one. The supply chain part is actually a challenge too, sitting in India for a lot of the avionics components, which are not so commonplace available in India. And you have to import them, and those costs are significant. And what we are really up against, and we are actually taking up the challenge, is to uh, identify partners within India who have the capability to customize these for us within India and indigenize the entire thing. The reason why it's not happened yet so far is because we don't really have a civil aviation, product development happening at scale in India yet. So the operative word here is scale, right? So there are electronics people who actually work for ISRO and DRDO, and they do supply to military aircraft and all that stuff. But for civilian aircraft, it's important that you need to be able to provide quality at low cost and at scale. And that's something that we would like to spawn over time. We can't do that for our first few aircraft because it's important for us to put out some product with certification and into the market. Could be expensive because we are importing components, but
Oh,
ultimately, it's important for us to actually spawn an indigenous, um, uh, you know, indigenous product. I mean, component development at scale, and that's something that we are up for over the next waves of certification of our product that we will put out. That's a second challenge, and the third challenge definitely that you mentioned is getting capital. So okay, getting capital in India is sort of like a peeling the onion one layer at a time, right? So we have to show a significant milestone to achieve because people have to first of all believe that it's possible to do these things in this part of the world, and then we go around asking for more money and all that stuff. The interesting thing is the amount of capital that we seem to need to get to the same level of milestone as anywhere else in the world seems to be of the order of about a tenth or a 20th of 10th, 20th of the capital itself is actually too hard here.
oh, oh.
Right? So that gap is actually pretty horrendous in the sense, yeah, I mean, if we were to actually be able to raise capital in the US and develop product in India, that would actually be like the paradise.
I see. I see.
Yeah,
And you are also involved with a lot of other startups,
correct.
like Galaxy, you mentioned, Agnicool, and the Tutor Hyperloop. So, what is the playbook of a successful deep tech startup as against the struggling one? Like if it right from raising funds to, you know, being there out in the market and selling your own products, what will
Yeah.
be?
So I remember this very clearly when early on in our first round of funding at both Agnicool as well as at ePlane,
Mhm,
we had this Silicon Valley super angel and a serial entrepreneur, uh, a, a person called Naval Ravikant, fairly well-known person, on who books have been written, by the way.
mhm,
So he told me this, right? He said there are three things about what we're doing that marks a difference.
mhm,
Number one is a globally competitive tech.
mhm,
So the first question that you asked, like, what is the USP, right?
mhm,
And there is a technical USP that is actually determined by what should be the business case.
mhm,
So if you're an air taxi, how do you actually make an aircraft that's an air taxi? If
mhm,
you're a rocket company, what is the pain point that you're actually solving for the customer for which you need to develop like a 3D printed rocket,
sure.
right, for an on-demand launch and so
Mhm,
on.
mhm,
So what's the business case that we have to solve and what's the technology that we have to develop for it?
mhm,
That's what makes us globally competitive. And
sure.
that's very important for any company anywhere in the world, that you have to actually have something that's globally competitive and not just mimicking something that's being done elsewhere in India. We don't do this for India's sake. We actually do this for the
World
global play,
class. Yes,
right?
certainly.
That's the point number one, right? That's how you will actually be able to prevail in the market in the first
Sure,
place.
sure.
The second thing is the frugality with which we are able to achieve this, right? At about the 10th or a 20th of the fundraise and so on. That is something that a lot of people don't seem to even understand. How is it possible,
Mhm,
right? So a
mhm,
lot of people actually ask me, how is it possible for you to actually pull it off, at a 10 to 20th cost?
mhm,
The answer is it's here for us to see. ISRO has actually been doing this for donkey's years, for the last 50 years, pulling off things that at shoestring budgets when compared to NASA or any other space agency.
mhm,
And as startups, we have to actually be even more frugal than ISRO, right? Because ISRO, at the end of the day, is a government
mhm,
agency. They do get their salaries from the government and all that stuff. Whereas in a startup, we don't have that kind of
mhm,
luxury, right? So that means that we have to be like super frugal than ISRO, which is like a huge benchmark by itself. So I
sure.
asked a question, returned back to them saying, well, you got to actually ask the people on the other side of the world why they are more expensive, because they are the ones who are actually doing it wrong. We are doing it right. So we don't have to actually justify why we are frugal, right? You have to ask the people who are not frugal why they are not frugal, right? So I think frugality is very natural to us, and we have to make sure that we are, holding on to that instead of splurging it out, like what other people going to do. Aerospace does not necessarily mean that you need to splurge. As a matter of fact, pretty much a lot of aerospace majors uh, who are worth their salt around the world actually have significant amount of design and manufacturing happening in India for exactly the same reason, right? So it's actually an open secret that India has the kind of talent pool that's globally competitive, that is coming at about a half to a tenth of a cost, right? I don't know how long it will last, but
Mm-hmm.
while it's there, we need to actually make use of it in the first place. The third reason that could actually be very significant when we ultimately succeed in putting out products of global, magnitude, will be that these things are happening in India, right? These things are coming out of India, right? That's the thing that he said will actually make it like a world news, and that was his reason why he wanted to be part of that story. So I believe that these are three, ingredients that would mark the success of the kind of startups that I am part of.
Sure.
If you ask me any of these individual companies, like whether it is Agnicol, or when I started about talking about ePlane, I also mentioned about Agnicol, Galaxy, or Tutor. I have not told you what is the USP there, but
Please.
there is always this technical USP. I'm not trying to elaborate, but there is always this technical USP that fits the business case. That's actually super important to begin with.
Sure, sure. I think Hyperloop is all about creating vacuum, and
Correct.
Galaxy
Correct.
is taking the images when the clouds are there or during the nighttime.
Absolutely.
It is all
Absolutely.
about that. Yeah.
Absolutely. Absolutely. And these are very unique. Like I think we don't know of any other satellite company that can do that yet
Mhm.
in the world. And with Tutor Hyperloop, for example, we can actually develop a tube that's at about one tenth of the cost of anywhere else, and so on. So, and that's because of the technology, not because the tube is cheaper in India.
So is it all incubated at IITM?
Correct. Yeah. So it's all actually being done. I think Galaxy moved out of Chennai and went to Bangalore after their incubation, but
Okay,
others are actually working out of the Discovery campus of IIT Madras, which is south of Chennai.
sure, sure. And you have seen with all these startups, you have seen the ecosystem has evolved. So
Mhm.
from last 10 years, right? We have been talking a lot about deep tech and all. What is still the gap that you see widely and which can be, cured?
I think one of the problems that we have seen while, I mean, right from the time I came back from the US,
Mhm.
after my PhD and postdoc, to join the faculty at IIT Madras, and it still somewhat continues to prevail, is a lack of trust in our own talent.
Mm.
So it requires a foreign company to come and identify our talent and set up an R&D center here to nurture the talent and develop products for themselves that actually go abroad, when compared to Indian companies actually trusting the talent and nurturing it to develop Indian products, or support startups that produce Indian products and so on. It's almost like Indian product is an oxymoron. Right. So yeah, I think that the trust factor is something that's hugely missing, and for that reason, investor purse strings are much more tight in compared to what they should be, generally those kinds of things, right? So, and then we always look up to the government for a panacea for everything, and it doesn't have to be that way, right? There must be a lot more private enterprise around technology
Sure.
that we trust, and of course, these technologies should be solving social problems in India and around the world.
Mhm.
So how do we actually identify people who are not just developing tech for tech's
Mhm.
sake,
Sick, sick.
and are actually solving real world problems?
Mhm.
And how do you spot that talent, and how do you nurture that in terms of funding or setting up funds for these particular purposes, is still needs to be a lot more pervasive than what it is. But it's been growing since. If you were to look 10 years back, it's actually an extremely patchy land. Now we have some oasis here and there. So hopefully the desert will the desert will dry up and we'll actually have a lot more fun flowing. Yeah.
See, I see, I see. You're seeing it changing,
Yeah.
right?
It is definitely changing. It's just that we wish it could change at a faster pace. Yeah, that's the only thing.
And what are your views? Like you mentioned autonomous and all. And so, what are your views on the convergence, technology convergence on AI, semiconductors, and aerospace tech? What do you see the opportunity? Like I am from the semiconductor industry. So, what are the
Yeah.
opportunities and where do you see all this technology is converging to?
Semiconductor. Yeah, yeah, yeah.
Hmm.
Yeah. So the thing about semiconductors and AI itself is actually a new combination.
Mhm.
In the last maybe 5 years, I would think, if you want to, if you want to actually think about like a tipping point where it started taking off, and it's going to grow, but it's actually extremely common to a lot of tech that's going to happen. So in our case, for example, we have been working closely with NVIDIA on the entire autonomy stack that we are building ourselves,
Interesting.
and bringing it as part of the avionics standards for aerospace applications.
Okay.
And that's kind of like a groundbreaking work that we're doing on how we fuse these sensors together at the edge with these GPU processors
Okay.
on board, so on. And how do I actually employ AI tools for sensing what's obstacles that are around the aircraft and all that stuff. So this you will find a lot more pervasive in not only aircraft but also driverless cars a lot more, and you'll see lots of gadgets around the home having these kinds of things, like for example vacuum cleaners cleaning the floor by itself because it can sense obstacles, and all those things, right from day-to-day gadgets that we use all the way to aircraft. This is going to be extremely powerful.
Mhm. Mhm.
Yeah,
And uh, you would have heard about 2047 vision about Viksit Bharat, right? India is
correct.
claiming that it will be leader in innovation. So, what do you think? What are the bold steps that aerospace tech can take to be there? And how can we increase the number of women because I see there is a lot of ratio difference, right? Especially in aerospace tech or this kind of niche tech.
Yeah, good question, very good question. So uh, I think what's going on today is actually some kind of an exponential movement, right? So it's sort of like what happened with China right in front of our eyes from 1980s, and if we have actually had like about a 20-year lag, and what those 20 years has actually added to China in terms of if you want to look at it as GDP or the kind of scale at which they are able to achieve things,
Mhm.
all of that stuff we can actually expect to happen and much more because of technology being what it is today, that can be easily adopted when compared to the kind of access to technology that China had 20 years back, where it had to develop a lot of things.
Mhm.
So we can expect this Viksit Bharat to happen somewhat naturally. We don't need to necessarily belabor the point. I believe that we will actually get there in style. That's number one. Very specifically on aerospace, I believe that we will have our own civilian aircraft, like for example, the likes of your Boeing and Airbus. So we will have an Indian answer to that. Like I think right now China is developing one such answer to the Boeings and Airbuses of the world, and I believe we'll also actually have something similar.
Sure.
In all probability, it could be electric or hybrid or hydrogen powered, which will be a lot more sustainable than what the world has seen before. So I think what we end up doing in India is to actually make sustainability sustainable. It's important for us to be able to develop sustainable technology that is closer. Not It's not only good for the planet but also good for the pocket.
Mhm.
So you need to have the double tech, if I can use that word,
Sure.
that is not just focused on making it greener but also easier on the pocket. And that's something that India is very good at doing. We will actually see more of that happen
Sure.
by 2047. And of course, we believe that we will have Hyperloop, linking multiple cities by 2047. That's a goal. It's not just a dream. It's not just an aim, but it's actually a goal that we will be going after. And I think urban air mobility should become commonplace by then. In addition to the aviation tech that I talked about, we might be scratching the surface, or maybe at application stage of even hypersonic flights that are intercontinental. The famous phrase that I keep using is Chennai to San Francisco in 4 hours kind of flights. Those are the frontiers that we should actually be knocking at by 2047, in my view. Yeah, I think all of that stuff is doable. I believe India is an aerospace nation. We have had the likes of Satish Dhawan and Abdul Kalam, and even prior to them, Vikram Sarabhai, these people have actually been like beacon lights for generations to come. And even when India was actually a very poor country back then, maybe a generation or two back, everybody would gasp for like rockets to fly out of our soil. And I used to feel like, guys, we don't even have food. I mean, why are we actually getting so tickled by rockets? And that's exactly what our culture is, right? So we have like a long-standing culture of this Pushpaka Vimana and all that stuff, right? That sort of inspires a lot of people, saying that we need to be at it. And I've seen this over and over again, people from extremely lower middle class getting, inspired by having to do aerospace. I'm like, how? And that's actually the magic of India. And talking of women, I think Agnikul, I don't know about the current numbers. We used to boast of about 40% women. At
Okay.
ePlane, our goal is to actually have 20% women, and we are actually edging towards that.
Sure.
Elsewhere in tech, it's actually lesser than 10%. So we are extremely gender conscious.
Okay.
And it also happens naturally in India. I think about 50% of India is women, particularly in the southern part of the country. We have lots of women participation. Like, let's say Kerala has like lots of women participation in tech development, and Tamil Nadu is not far behind, and so on. So they are actually getting into the workforce. They need to be part of the ecosystem and so on. Of course, there could be some slowdown due to childbirth, but there's a lot of supportive care today, and a lot more sensitivity around it, that we are very supportive of. And we're very proud about the fact that we need to have so many women in the workforce. And that's happening as well, much better than anywhere else in the world.
Sure, sure, Professor Satya. And just the last question, like, what do you enjoy? I mean, how do you manage this multiple hats, being a professor, being a founder, being an advisor to so many startups? How do you
Yeah,
manage?
I think, yeah. So the thing about a professor is that we do things outside of the classroom, which we synthesize and bring to the classroom, right? So the students actually have a ringside view of what's happening in the tech development firmament around, right? So if you were to work with an ISRO or a DRDO, or a GE or any of these industry, we would actually, in some form, bring it to the classroom, form electives that we will teach, and so on. So students do enjoy what's happening in real time pretty much.
Mhm.
That's the mark of a teacher. And that continues to happen when we have these startups as well, because we are able to give very live examples in the classroom of how we are developing products in these startups. And these products are actually really at the cutting edge. So we enjoy scratching our head, putting our heads down, and thinking hard on fundamentals. So it's all about applying first principles, and going back to the basics all the time. So that way, I'm actually really challenged as a professor every day, and that's extremely exciting for me. Yeah.
All right. Thank you, Professor Satya, for giving us the time. And it was truly an honor to have you in our podcast. And I would certainly do with you 2.0 because I would be there in Chennai and then I would be, I mean,
Please
I would
visit
be
us.
talking to you.
Please visit our facilities. I'm pretty sure you'll actually be enjoying your visit. Yeah.
Yeah. Thank you. Thank you, everyone. Please subscribe to our channel. Thank you.
Thank you.